Hello students, in this video part 2 for grade 6 science exam, we will discuss some of the science topics which will be very important for the examination of grade 6 science. So let us start. So first topic which is important for the science exam for grade 6 is water cycle. You can see a cycle for water. Cycle is something which is round, so you can see the arrows making a round here. See, round. The ground on the surface of the earth, it goes up and comes back to the same place, and this is called water cycle. You can see there is a circle, there is a round here, that is called water cycle. So the water in the river, for example, takes heat from the sun and then it becomes vapor, gas. We call this process evaporation. And then this, here it becomes cloud. This gas becomes cloud here, makes cloud here. And this cloud, after, heat release, it means after giving the heat from the cloud gives heat away. It means the clouds become cool. Clouds cools down. When clouds cools down, that process is called condensation. And this after condensation we get water, we get rain, because after it becomes water, and it starts falling down, and that falling down is called precipitation. In common word we can say rain, and then precipitation, and then the water comes again, which is collection. So this is complete one round, and that's why we call it water cycle. George wanted to model two processes that cycle water in the atmosphere for a class project. He began by filling a self-sealing plastic bag that has water. After sealing the bag, he taped it to a sunny window. After some hours, water beaded along the inside of the bag. Which process are represented by this model? So it is evaporation is happening and condensation is happening. Evaporation is happening because it is kept in the sun, and condensation is happening because of there is some cooling happening inside, and that's why there is condensation is happening together with evaporation. Now here in this image, the transfer of energy in the photo above, which statement is the best described? So see, when water changes state from a liquid to a solid, thermal energy is released. In this image you can see there is ice formation. The solid is coming from liquid, the water is making ice. So what happens? There is cooling down, thermal energy is released, thermal energy is taken out. I told in the previous video that thermal energy is heat, so heat is released, heat is taken out. If we see the other statements, when water changes state from a liquid to solid, thermal energy is absorbed. No, it's wrong. Thermal energy is taken out. When water changes state from solid to liquid, see here, solid to liquid is not happening, so this is also wrong. And D is when water changes state from solid to liquid, thermal energy is released. See, solid to liquid is not happening here, so that's why the last statement is also wrong. C is the right one. Now you can see this picture as a gas particles. We discussed before that when we go from gas particles to the liquid, see, After condensing, gas becomes liquid. After condensation, gas becomes liquid. So what is happening? Potential energy is increasing or decreasing? It is increasing. The bond is increasing. The attraction is increasing between the particles. And that is attractive forces also that is increasing. You can see the particles are closer. Here they were fighting, kind of they are energetic, they are fighting, but here now they decided to move closer, come closer. So attractive forces are here more. Now here in this is solid, clearly solid, and after melting it becomes liquid. So what about potential energy? It, see, this is bonding. Here you see the bonding more, here we see the less bonding. So potential energy is decreasing, attractive forces decreasing. Here most attractive forces, we have done similar type of slide before in the part 1 video. Now here the C question, you can see the it is liquid and it is boiling, becoming gas. Oh, a lot of decrease in the potential energy, and attractive force also decreasing. They have decided to run away from each other, they don't have any bonding, they don't love each other. Okay, so they are going away. Okay, so next is we have a figure here, and we can see we need to know the process that changes liquid into liquid water to water vapor. We need to label the transfer of energy. Okay, so we can see this arrows showing that this water is becoming gas and moving up, rising up. That process is called evaporation. Evaporation, changing of water into vapor, changing of water into vapor. See, vapor word is here and vapor word is in here also. Next is energy transfer. Next is energy transfer. Thermal energy from the sun is absorbed by the water. The water takes the thermal energy of the sun. I say again, thermal energy is heat. The water then changes into vapor. Now, how does energy from the sun drive the cycling of matter? So, this is the explanation. Now, four friends noticed this water in the morning, and then they were going to school, and then after they returned, they noticed that there is some water gone. So they four have different ideas. So they see, the boy told that I think the water soaked into the bricks. Other boy says, I think the water went up on into the clouds. So no, it does not go so quickly into the clouds. And that boy says that it go soaked into the brick. See, the brick does not absorb too much water. And then Max says that I think the water is in the air around us. So his statement is correct, because after the 4 or 5 hours, the sun heat takes the water into the water vapor, and that vapor is in around air, you know. And the last boy says, I think the sun changed it into something else. No, can't be. The water, only the change in the state, it becomes gas only. You can't make something else from water. So that's why we need to circle this boy, because this answer is we agree most with. Now water change into vapor and is in the air around us. Why do clouds and other bodies of water disappear? Easy answer, evaporation. Evaporation makes the water go. Like you have noticed in the kitchen, you put some water in a kettle on the stove. After some time, you see the water becomes vapor. There is no water left into the kettle. So that process is called evaporation. Heat from the sun transfers into clouds and other bodies of water like lake, river, ocean, and that changes into vapor. That changes into vapor is called evaporation. How else does water enter the atmosphere? Very good question. We know that evaporation helps water enters the atmosphere. What else? So these three are very important. Number one is transpiration from plants. Number two is respiration from some animals. And number three is the water stored in the tissues of animals and plants after their death. That water also goes to the atmosphere after decomposing of the dead bodies, dead plants. Now, other than evaporation, water enters the atmosphere through transpiration from plants. Some plants leave water vapor through the leaves, you know, and some animals also they do respiration. The water vapor comes out of their bodies, especially from the mouth, through the nose. So not only evaporation helps to water to enter into the atmosphere, but transpiration, respiration also help. And as I said, water stored in there is water in every organism. So after death of the plants and other animals, they decompose and the water goes to the atmosphere. Now, in this question, Jenny had a bowl of hot soup for lunch. The soup was so hot, she decided to put it in the refrigerator for a few minutes to cool it. What happened to cool the soup so Jenny could eat it? So the heat moved from the soup to the cold air in the refrigerator. In the previous slide, we studied that heat comes from the high temperature body to the low temperature body. So here high temperature body is the soup, low temperature body is the refrigerator, and the heat moves from the soup to the cold air in the refrigerator. If we see option number B, the cold in the refrigerator moved into the hot soup, no, cold does not move. And C, option C, no heat or cold moved out of or into the soup. This is wrong. It just cooled off? No, it can't be just cooled off. Actually, heat moved out of the soup, which is option number A. Now this is there is a water here in this tray, and the water is 10 degrees Celsius temperature. It is placed in the freezer. We need to add arrows. We need to see the show the arrow sign to energy transfer, to heat transfer. So heat is coming from 10 degrees Celsius water to freezer. Before we discussed that heat transfers from high temperature body to low temperature body. So that's why the arrow of the direction of the arrow is towards the right. So it gives the energy out. That's why the arrow is outside, and that energy is taken by the freezer. So that's why it is taking the arrow is towards the freezer. Jane was drinking a glass of water. She asked her father where the water came from. Her father told from groundwater. Now Jane wondered what the water looked like underground. So her family said, her mom said, I think it looks like a huge ocean underground. Dad says, I think it looks like a small lake underground. Jack says, I think it seeps into the little holes or spaces between the soil and the rocks. Annie says, I think it looks like a long underground tube filled with water. No. It looks like an underground volcano. No. So, this is the perfect answer. I think it seeps into the little holes or spaces between the soil and the rocks, and that is the underground water. There is nothing like ocean underground, there is nothing like lake underground. So, the Jack's answer is the right answer. Now, why the Jack's answer is the right answer is here. See, this is underground. You can see the blue is the water. Blue color is water. Inside the underground, between the rocks, between the spaces, is water that falls to earth. Groundwater is water that falls to the earth through precipitation. Precipitation, the simple word is rain. Rain. Precipitation is rain and soaks down into the ground. The water goes into the ground. It fills in the tiny spaces or pores between soil and rock underground. And this is, interestingly, this is source of fresh water. How might a single drop of water travel from a cloud to a stream to an aquifer? So yeah, this happening. Water falls to earth's surface as precipitation. Precipitation, it means rain, in the form of rain or snow or sleet or hail. See, the precipitation is a general term for falling water. It can be rain, it can be snowfall, sleet, or hail. The water can enter the ocean or other bodies of water or seep into the ground to become groundwater. See, aquifer is the water and the source underground for the water. Why does water on Earth's surface flow and where does it go? So, the gravity helps the water on the Earth's surface flow. Where does it go? It goes to the ocean or it goes into the ground also, into the ground, underground. Okay. Water flows into and out of streams via precipitation and groundwater flow. Finally, it enters the ocean. What force causes groundwater to flow? Again, the gravity. Gravity causes groundwater to flow from high to low areas. As you can see in this picture, from high area to low area, groundwater flows. Now, there is a question to create a graphic organizer that illustrates the role of gravity in keeping water moving on Earth. So here is a graphics. Gravity force, which is pulling things down to Earth, that is called gravity. Gravity is a force actually, which is pulling everything down on the Earth. Now, gravity causes precipitation, and which is rain, and all going down on the floor, and then runoff. Gravity allows water to move down towards the reservoirs for storage in the oceans, rivers, glaciers, or stream. They each have differing opinions of why the stream moves along Earth's surface. Again, this is because of the gravity we have already discussed. Now, what is the albedo? Albedo is actually the reflectivity. Like some you have some cloths which reflects more than other cloths which reflects less. So see in this picture you can see high albedo. This surface reflects most This surface reflects some, this gray color. This white color reflects more, and this black color, dark color, does not reflect at all. So this surface white has high albedo, this has medium albedo, and this has the low albedo. So high albedo is for with eyes, thick cloud, light color like white, and low albedo for dark color, dark surfaces, soil. This is measure of the reflectivity of a surface. High albedo means less absorption, less taking. It is giving more. High albedo, it is not taking the heat, it is giving back. Okay, I don't want, you take like this. Okay, now land and water has different albedo. Land and water, they reflect differently. Water absorbs and releases heat slower than the land. See, water absorbs slowly, land absorbs heat faster than the water, and so it cools also, it reflects also. Water reflects slowly, land reflects faster. So, four friends are at the beach on a sunny day. They notice that the sand is much warmer than the ocean water. They wondered, and this is a sunny day, okay? They noticed that the sand is much warmer than the ocean water. They wondered why the temperatures of these surfaces are different, even though they are exposed to the same amount of sunlight. Very good question, this is. So water and the sand in the same sunlight, okay, but why sand is heat more warm than the water? Because sand heats faster, water heats slower, and heat, specific heat of water is more, specific heat of sand is very less. It gets heated quickly with a small amount of heat. This needs a lot of amount of heat, water, so that's why it happening. So Carla has the right answer. I think that land warms faster than the ocean because water requires more energy to be heated. That's the right answer. What effect does the sun have on water? Wow, this is very basic question. What sun does to the water on the earth? Oh, so this heats the water. That's it for sure. It's very easy to know. The sun is the source of heat for the earth, and this heat causes water on the earth to evaporate. And evaporation, or we can say it helps in water cycle. This heat causes wind also, which moves the surface water of the ocean. So the sun, because of the heat, there is a wind, and that wind moves the ocean water. And because of the heat from the sun, the water gets evaporated, it becomes gas. Energy transfer between the sun and the earth. Heat comes from the sun to the earth in the form of radiation, and then conduction also taking place, convection taking place. We have done radiation, conduction, and convection. We have understood what are these things, in the previous slide. And then there is energy transfer here also. The plants take energy from the sun and make food them for themselves, and that food we also eat. Actually, we get food from the plants, yes. And how they make food? Because of the sunlight, because of the heat of the sun. Land breeze. Land breeze is the wind coming from the lands, land towards land. And what happens is actually, so at night, the water takes more time to cool down. On the other hand, the land cools faster. So as a result, what happens is the water, the temperature over the water, temperature over the water is is hotter, warmer than the temperature over the land. So the air goes up from the ocean surface. The air goes up, and there is a low pressure area. So the air from that land area comes to this area for the towards the low pressure area. We know that wind flows from high pressure to low pressure area. So this wind, which is cold wind, cold air, comes towards this, and the hot air goes up, and this keeps on repeating, and this is called land breeze. Predict whether a sea breeze could occur at night. So a sea breeze could occur at night if the land is warmer than seawater. It can happen. Sea breeze can happen at night, and but the condition is the land must be warmer than seawater. But usually it does not happen. At night, land is cooler than the sea. Suppose you go to the beach in the morning of a sunny summer day. Explain the rate at which thermal energy is absorbed by the water, sand, and air during the day. Heat absorption by sand is faster than that by air, and that is faster than that of water. So sand absorbs the heat fastest, faster than the air, and air absorbs heat faster than water. Water is the slowest to absorb the heat, because we discussed before that water has high specific heat. As the sun begins to set, predict the effect on the rate at which the air, water, and sand will cool. This question is similar to before slide, because in the last slide that we were talking about heating, and now here we are talking about the cooling. So cooling is faster, like heating, it is faster in sand than air and than water. Explain why the flow of energy between air and sand is different than between air and water, as thermal energy is absorbed from day to night. So water has a higher specific heat than that of land. Air has low specific heat than that of land on water. Therefore, energy is transferred faster between land and air than between water and air. In this picture, use the photo to describe areas of high and low albedo and explain. You can see this has more reflectivity. This top of the mountain, peak of the mountain is clearly visible, that is reflecting the most, and this is having high albedo. And the low areas, the grass, the field, the trees, the green, the dark color at the bottom of the mountain has the low albedo. So low albedo for the dark color, and light color has high albedo. We have discussed before. These are the questions only which we are practicing for the examination. Diagram, here is a diagram. Create a visual to show how energy is transferred from the sun to earth and the atmosphere. So it is happening through conduction, convection, radiation. Radiation can take place without particles as well. Conduction solid, liquid, and gas. Convection in liquid and gas only. These three are actually the methods of heat transfer. Following features on the earth affect the transfer of energy. There is a question, which features on the earth affect the transfer of energy? The answer is land and ocean. Land and ocean can change the transfer of energy, because the land has different specific heat, ocean has different specific heat. It means land takes heat faster, ocean takes heat slower, land cools faster, ocean cools slower. Okay, and there is different feature because of the color of the surfaces also. If you have light color, that reflects more. If you have any surface which is dark color, that does not reflect at all. So there is a change in transfer because of these features. What energy ultimately drives convection in the oceans? So we can say the thermal energy, the heat from the sun. We have discussed all earlier in this video and the previous video that thermal energy is heat, heat. Now, global conveyor belt. What is global conveyor belt? So it's a conveyor belt, in the supermarket, when we at the cash counter, when we put our stuffs to pay, there is a belt, small belt, conveyor belt. We put our items and that moves towards the cashier. So similarly, we have global conveyor belt. Not similarly, but we have global conveyor belt. Global, it means for the world, and conveyor something which is moving. uh, Three types of currents, combination of surface currents, upwelling and density currents, are combined, called global conveyor belt. Actually, these are the wind, these are the motion of the water, surface current in the ocean. Upwelling, it is water coming towards the surface from the bottom, and density currents is the water from cold water going towards the cold water and hot water. Because of the temperature difference, they move. So these three types of water motion combinedly we call global conveyor belt. I repeat, global conveyor belt is the combination of number one, surface current, number two, upwelling, and number three, density current. And what this affects, I mean, what does a global conveyor belt has, the effects? So it affects weather and climate. Very importantly, this affects our weather and climate. What causes wind to blow? This is very basic question, but it is interesting to know that because of the temperature difference, there is a difference in the air pressure. Hot, that hot air goes up, so there is a low pressure area, and then the cold air has a lot of air, and there is a high pressure area. So because of the low pressure area, cold air comes into that area to fill, and because of this, the wind moves, wind blows, cold air settles down because of high pressure, air from high pressure area comes to low pressure area. See, and this cause wind to blow. If there is no difference in the temperature, there will be no difference in the pressure, there will be no blow of wind. Okay, very interesting. So the ultimate source is the sun is creating these things, these differences. Okay, not these differences, but the heat from the sun is causing these things. And because of the surface of the earth is not plain, it is uneven. Somewhere it is ocean, somewhere it is land. Because of these different features, there is difference in the temperature. What are the global wind systems? So the global wind systems are three: trade winds, polar easterlies, and westerlies. What is the nature of this? So trade winds is steady direction, east to west, 30-degree north latitude and 30 degrees south latitude. The location on the earth is this one for these winds. Polar easterlies, near the north pole and the south pole, and this is usually cold, because in the north pole and south pole there is a too many glaciers, a lot of ice cover, and the east to west, the direction is east to west. Only westerlies has the direction west to east, and it is steady. And the easterlies here and trade winds both have directions east to west, and the westerlies location is between latitudes 30 to 60, both sides, in the north and in the south. Imagine you are entering a large AC building on a hot summer day. As you open the door, you feel cool air rushing past you out of the building. Why it is happening? So inside the building there is a cold air, which is high pressure area, and outside, the because of the summer, the air is rising up, so there is a low pressure area. So to fill the low pressure area, when you open the door of the building, the cold heavy air comes out. Okay. How does the wind influence the movement of water? Yeah, definitely. Wind helps to move water, on the surface water of the ocean. Uh, it, it helps. Wind helps. Wind transfer energy to the water in the sea. See, when wind flows over the water, that moves water as well. When wind blows across the ocean surface and pushes water away from an area, deeper, colder water is then forced to the surface. Deeper, colder water is then forced to the surface. And thank you for watching this video. Thank you. Good luck.